all of those things as we journey. Okay, so having accepted my apologies, I think I can now continue. I hope my screen is visible, right?
No.
Okay, it's not. Oh.
And please, sir, can I say something, sir?
Please go on.
So this will be this will be my first time joining this section. The last section, which I think I was not, I didn't join. Probably I've not joined the group then. So some things are sounding new and light to me, and I don't know if there's a way you can help us. If probably with the recording of the last class, or I don't know, something like that, sir.
In fact, thank you. I need to talk about that recording because there are some people that have tried their best to make me commit suicide or strangulate me online. I don't know how you guys do it, whether it's through Bluetooth or stuff. That's because of that recording stuff. Please, like my colleague posted on the platform, I think the window was open for some minutes, so some people had to respond, even though they had chatted me up also. You see, the issue of that video. The video is going to be sent. It is not necessarily in my power at the moment to get that sent, but it is not as though there's one problem we are trying to avoid. No, there are some editings that are going on here before it is actually sent. That's one of the reasons why I sent that resource. There was one resource material I sent on Friday or Saturday, even though the class did not hold. I sent that material with the intention that you go through them, and on account of going through them, you can learn the needful. But you can trust me that the stuff that you need are still going to come. That is the material, the live recorded videos. You are still going to have them, but in the meantime, try to fraternize with that resource material that was sent, especially the last slide. Right, that is the last page of that slide that was sent. That was why I wrote about. There were links there, so if you click on those links, it will lead you to some places at least to help you for the basics, the beginning stuff that you want to do. So for that, my lady that just spoke now. First of all, welcome to Nigeria Youth Drive. I would urge you.
Thank you, sir.
Yeah, it's fine. I would urge you to go to the group chat. We'll resend that again so that you can use it to fast track what you want to do. Okay, thank you very much. Okay, so today, yeah, that's fine. So let me run everything I have done because I really don't want to go back and keep doing. Oh God, let's just keep venting. Okay. Okay, so today I want us to move on to greater things. I want us to move on to greater things, and so today we are going to start modules and packages. So we are going to introduce us into some modules, like some major modules that we'll be using now in data science, at least for our exploratory data analysis and stuff like that. So modules and packages. So let me explain what they are. Python is such a I said one of the intentions of programming languages is to make your life easier. So in order for that to happen in the Python programming language, one of the things that was done was that other people began to contribute to Python to Python. So people began to create things that when you just integrate them, like once they are called upon, they are like scripts, just like this notebook that we have. They are like Python scripts that contain certain functionalities that once they are called, you have the ability to perform anything as long as it is what is defined in the functions of that script. For instance, when I started learning Python and observed that Python can do a whole lot of stuff, I began to try out some things. I was into video editing, but the system I was making use of those times was not so efficient enough to do a whole wonderful things. Please, is my screen visible now?
Yes.
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 Oh, okay. So when I realized, then we had learned about frameworks like Python, I mean like Pandas and Numpy and some other ones. And I had read some articles that said that, in fact, I see people say, just think about it and Python can literally do it. And as funny as that may sound, and also as exaggerated as that is, it is almost true. Just think of that task that you want to do, that you feel you may not be able to do. Actually, Python can do it. So there were times when the system was just so bad that even to unzip a file was very, very strange to do that. I would just go online and just ask how to use Python to unzip. In fact, that was how I started learning Python in more advanced ways. So how to use Python to unzip a file, how to use Python to cut and trim videos. Funnily, there were packages online. Like they were already created packages online that are created in Python. Once you call the functionalities of those stuff, you will see those things work out. So when I was editing some of my videos, I did not necessarily need to download all those Filmora, CapCut, and the rest of them. There were packages created in Python that could help all of those things to work out very seamlessly. In Python, or let's say for data science, because Python is not only for data science, it's a multi-purpose programming language. Backend guys use it. In fact, recently, data scientists have started almost feeling like front-end engineers, even though definitely they are not, because of one package they call Streamlit. Streamlit is making everything very easy. So after you have done all of the stuff that you have done in these notebooks, some newbies in programming would ask you what you are doing because they really cannot see what you are doing. If it's a front-end guy, they are seeing a phone being displayed by the side or a website being created. But your own, you will just start using your mouth to tell them it's just a model, it can predict this. I can gain insights. If you give me data, I can gain insights into this and this. For the data analyst, it is even better for them because they always create dashboards that make things easier for them. But recently for Python programmers, Streamlit came out and started making it very, very easy. Meanwhile, that Streamlit I'm speaking about is a package, or let's call it a module. So they are just Python scripts that have functionalities that are tailored to a particular task. So all you need is just to import them and make use of them. So the major thing is just learning how they function. They have lots of functionalities. The aim is not to learn all the functionalities that those packages have. It's not to learn all. It's just to think of where you want to apply it and then apply those functionalities there. You get? So that's a package or a module has 10,000 functions. Does not mean you need to know all the 10,000 functions. You only need to find yourself in a situation where those functions will be needed and then see how they are being used and use them out. So don't it was one of the reasons why in the last class I said you don't in this stuff, you don't necessarily need to cram all the lines of code. You need to just understand the logic behind them. And by the understanding of those logic, it will guide you into what you need to do. In the programming world, in fact, you are open to asking questions. You are open to asking senior colleagues, mentors, go online, Stack Overflow. These days, AI is one of the go-to tools. So anybody that has issues just goes there. But the only problem with the use of AI is that people just copy and paste code. They don't try to understand it. In fact, most times AI can even make your work much more complex than it is supposed to be if you don't understand the code. But it will not still annul the fact that it makes your life easier. So there is nothing wrong in you having questions or dysfunctionalities with regards to some packages, and then deciding to ask to get questions to help you just solve them. So let me just give this a definition. So modules, bracket packages, are Python scripts, permit me, that contains certain functionalities that are tailored to a particular task or set of function or set of function. Yeah. Just a definition coming out of my head. So in our Jupyter notebook, some packages now I will use those two terms interchangeably. They have little differences, but it's not necessary. But I'm going to use them interchangeably. So anytime you hear me say module or package, I'm making reference to the same thing. In our Jupyter notebook, especially here in Google Colab, there are some packages or modules that are already built in. So that means you will not need to install them. Okay, that will lead me to something. This step to using packages. So the first one should be to install the package. Just install the package, and then the next one would be to import it. There are two different: import the package, and then just perform any task that you need to perform. Yeah, so this is going to be the idea. Now let me start with the explanation of this stuff now. So I said, in making use of packages, you first of all import, and you would install, then you would import, then you would start performing tasks. You get. Let me show you something here. Pandas. Let's use pandas documentation. Okay, yeah. Perhaps check it in PyPy. Okay, let's see documentation. I just want you to see something here. Let's not use this. Let's check PyPy. Okay. So this is one of the major frameworks that we're making use of, but we are not making use of it now. I just want to explain something to us. I wanted to see some after having that, I wanted to see a set of scripts that relates to this, so that I will show you certain functionalities and then tell you how that we do not necessarily need to use all of them. Okay, so, well, it's fine. Since that is not up, let us just consider the following packages. So one is Numpy, other is pandas. Next one is matplots, right? Stbon, plotly, yeah, and then let's say scikit-learn. Don't worry, you're not going to be confused. So let's try to explain using pandas. So explaining using Numpy. So I said the first thing that you do is to first of all install the package. In this Google Colab, some packages are readily available. You get it still does not know the fact that we need to install them first. So before you make use of any package, you have to first of all install it. So how you do it in Python is you do pip install, call the package name numpy. So that's how you literally download it. So you have already downloaded it. Yes, let's just wait for this guy to stop loading. Okay, so you see it now. So that is always the first thing. Yeah, it may not be necessary in this Google Colab sheet because, and the major reason is actually because Google Colab already has it in place, but we are still going to do that. So after doing that, the next thing is to import. Remember, you install first, then you import. So if you want to import, there are three major ways to import packages. Now, you can import a package, and by the lines of code that you use in importing that package, you will have access to all the functionalities that the package represents. All of them, all the functionalities, all. Watch this. Import, let's say import numpy. I've downloaded numpy. So now I want to make use of it. I use import numpy. This is one way to import numpy. There's another way. You can do import numpy as np. I will tell you the reason for this. Okay. There's another way again. You can do from numpy import square root function. So look at these three things. They are very, very correct. But when you are importing, you import things as they relate to your use case. Let's start with understanding numpy. This would help me tailor this thing better. Okay. Numpy is the number one package in Python that we use for interacting with numbers. When we want to deal with mathematical interactions, one major tool, one major package that is used in Python, any math function that you want to perform, at least to a very good extent, any mathematical function that you want to, or mathematical operation that you want to engage in, numpy is that go-to package that you think of. Is there someone speaking there? Okay, so numpy is that go-to package that you go to, that you make use of. In fact, you would always make use of it as a data scientist. You would always make use of it, always. So you see this line of code here that says import numpy. What you have done is you have imported any functionality that numpy can perform. If it can, for the mathematics students, if Fourier series is a function in numpy, with this call, with this import numpy, you can perform the Fourier series stuff there. If you want to deal with complex numbers, you can still use this import numpy to handle that. If you want to deal with any form of differential equation, if it is a function in numpy, you can also use this to achieve that. Think of any mathematical operation. Just think of any mathematical operation. If it is a functionality in numpy, if it is, then you can do it. So any form of functionality that is embedded in the numpy package, once you use this import numpy, you will gain access to it. Now, okay, let me write that there. And it gives you access to every functionality in the package. Now, this one is very similar. Import numpy as np. In fact, it's the same thing as the one above. The only distinction is that when you are programming, most times you want to do your work fast. You don't want to spend unnecessary time having to write. Imagine a package as long as scikit-learn. You may feel like that stuff is not long until you want to start doing some very crazy stuff, and you start feeling like having to write scikit-learn all together is you will just realize that it is stressful having to repeatedly write that, you get, or seaborn or streamlit. You start seeing yourself always typing things like that. No. So this NP is just a representation of NumPy. So rather than me having NumPy, I can write it as NP. So if there's a need to call any function, it still gives me access. It's just the same as this. It gives me access to every functionality that is embedded in the NumPy framework. The only difference here is that this time around, rather than having to write NumPy in full, when there's a need to call that framework, I will just make use of NP. There will be no need for me to use NumPy in full. When we start writing some lines of code, you would understand more about what I've said. Let me say that again. Import NumPy line, what that does is that it gives you access to every functionality in the package. The same thing happens in import NumPy as NP. It gives you access to every functionality in the package. Okay, using the alias, it's NP. Now let's go to this. This one said, from NumPy, import the square root function. So you see that SQRT speaks about square root. So I want to perform the square root of a number. So what this one does is that in the NumPy package, what it has done is it has extracted just one functionality. And that is the only functionality that it will be able to do. There's no other, as big as NumPy is, it cannot perform any other operation other than square root. So NumPy will only be able to use the square root function. It will not be able to do any other thing. It cannot perform any form of trigonometric operation. It cannot perform any form of matrix-based operation. It cannot perform any form of just think about any process that you can do with numbers. It will not be able to perform it. It would only stick to performing square root. So anything other than square root, it has no business there. You get that? So this one just gives us access to only the square root function. You get? So that's about that. Let me go back and add that here. So to import a package. So this is how we import a package here. You can do so. These are the 3 steps. One is import the package. Let's package name. The package name. Or let me do what we always used to. There's a reason why I don't want to make that. So import the package name. So this is the first approach. Then the second one is import package name. The package name as an alias. I'll still have to tell us something about this alias. The other approach is from package name. From package name, import a given functionality. So I just explained what I just did here. This one you can use. It's either you use this, or you use this. Now I'm going to give us a particular convention. That is, it is what every developer makes use of. When you're writing codes, you want to write codes that other developers can easily relate with. Yet every other Python developer at least can relate with it. So there are particular alias that every developer is used to. So if you don't want to confuse people because you are this brainiac that does things in strange ways, there are sign conventions or there are particular styles that we always use packages as, and it is best to just sustain those use cases you get. Now, I want to explain NumPy, and I started with using it to explain the way we are going to deal with every other framework that we are going to deal with you get today and in coming classes. Because I'm not just going to be doing the square root operation, then it is best that I make use of either this second line of code or the first one. But the major reason why I'm not going to use the first one, rather I will make use of the second one, is because I do not want to waste time. Like this alias that I have is shorter than having to write numpy and having to write just np. I mean, just writing np is less stress than typing numpy. So I'm going to make use of that. So let's assume that this cell number 32 does not exist. Let's just assume it doesn't exist. So I want to, the first step in using a package was to install the package, which I did at the top here. I told you how you do that. You said pip install numpy. You can do it that way. Any package you have, you just do pip install that package. Let me add that also here. So to install the package, yeah. So just do all this pip install. Okay, so the package name, depending on the convention that is being used. Okay, so you have already installed the package. So the next thing is to import it. We are assuming that this cell 32 does not exist. So let's import it now. So I'll do import numpy as np. So this is the second thing I'm to do after doing this. So far I don't think there is any question. So let me progress. Don't think there's any. Let me look into the chat if I continue. Okay, there's none. Okay, so now we are dealing with NumPy. Hello? I said, okay.
Hello, sir.
Yes, sir.
Good morning, sir. Can I ask a question quickly?
Feel free, sir.
Hello?
Feel free. Yes.
Okay,
please
so I wanted to ask you, sir. I've been hearing this Google Colab, and so I wanted to ask you, what is the difference, or what are the main advantages between using Python, right? Using Python, I mean using the software Python, right? Between using the Google Colab, what is the difference? Because people that train data scientists, they always go up to Google Colab to use Google Colab for. So I don't know whether as we're being trained on Python, once we become masters, we're going to be using Colab instead of using the Python software. So I don't know what distinguishes between these two. Thank you.
Okay, thank you. Okay, please let me also apologize. I'm hearing things here that I cannot I can't hear you. I'm really sorry. Please, anytime something like that occurs, just unmute yourself and speak. I'll give us that grace, please. Just unmute yourself and speak. Once I'm focusing on the Google Colab notebook, I would not always turn back to this interface here to see what is going on, so that I can concentrate there. So I really apologize, but I hope you can hear me better now, right?
Yes, I can.
Okay. So sorry about what was happening all of those times. Yeah, so sorry about that. Okay. So let me respond to Mr. Moses. Let me respond to Mr. Moses now. This is the thing here. Inside your local PC, if you want to make use of Python, they always ask you, especially for data scientists, they always ask you to download Jupyter Notebook, at times through the Anaconda. Yes, they always tell you to download it there and then you use that there. But okay, the truth is that both of them have advantages and disadvantages. So I'm not going to try to praise Google Colab and make it look like it is the boss. For instance, when you start working with other developers, back-end developers and front-end guys, you cannot interact, they cannot consume what you have, the endpoints, the stuff that you have created, they cannot consume it if what you're having is actually just a Jupyter notebook that is stored online in your Google Colab repository. So most times you would have to make use of a Python script itself inside your PC. And then the only disadvantage and reason why we prefer to make use, me for one, I prefer using my Google Colab, especially when I'm doing experimentation or I'm just working on data science projects, notebook-based projects. I prefer to use Google Colab. This is my own reason, because I feel it's actually better in the sense that, one, when you start working with advanced models, advanced packages like let's say PyTorch, Keras, TensorFlow, Flask, FastAPI, depending, PyTest, they are doing bigger things. You realize that when you start building models or training models that are really heavy, dealing with neural networks, when you are training very heavy models, I've seen situations. Then I was hearing about, that situation whereby you've heard people talk about all of these stuffs and you are so excited, you want to try them. I was using a PC whose storage capacity was not even very, very good. And then I was always used to working, like you said, using your local PC and trying everything out there. So I tried. I just watched a video on neural networks, to be specific, image classification, CNN. So I tried it in my PC. It got to a point when I was training the model, my system was literally shaking. Like I was hearing one funny sound. Like I was, those movies you watch where you feel like an alien wants to come out of your system. Yet that was actually the feeling I was scared. I stood up because I have not experienced that in all my lifetime using that PC. You get, so it was like my system was going to transform it. It was going to convert itself into one transformer, and then I will now start shouting, a demon, this funny, those stuff you watch in sci-fi movies. It was like that's what was going to happen. You get, and then I realized that the system, local PCs, except when you are using some really crazy laptops, you get, they may be able to handle those things. But even people that make use of those stuff, because they know that they will always go online to search things out. So what is the essence of still having to make use of Jupyter Notebook that is inside your PC? Always connect once you are working as a data scientist, just know that you have signed into consuming data. Don't be scared. Provision would always be made. I used to be that way, so I was always scared that how many gig would I consume every day. But I think you should just give yourself out to it. The Google Colab has storage, like it makes use of there is access to GPUs that normally most of our PCs would not have. Online servers that helps you to store what you are doing. So even if you are working with very, very big models, you have you can have seamless flow when you are using Google Colab than when you are using your Jupyter notebooks. So that's why I feel it's actually best. It's one of the reasons. You can also just browse it out on Google. You'll see several reasons. But for me, ever since I started using it, I don't have those stuff. I don't have Jupyter Notebook itself installed in my PC. I really do not see the need for it. Please, this is going to be the last question on this that I'm going to answer. That is Harun. So Mr. Moses, I hope I've dealt with that, right? Thank you.
Yes,
so,
yes, thanks.
Yeah, good morning.
I will follow.
It's fine.
Hello, good morning.
Yeah, I'm with you.
Yeah, Harun speaking. Okay. Sorry, I missed the first class.
Okay.
Yes, I don't know.
Okay, sir.
My question goes like this. Google Colab, because I can tell you this is actually my first time of hearing about Google Colab.
Oh, okay, it's fine.
Yes, so immediately you may mention, I just quickly have to check and see what it looks like. It's just like a workspace, right?
Yeah, sure.
It's a workspace for data scientists and data machine learning and the data engineers.
Yes.
That you have
definitely.
loaded softwares that you can actually draw from and make use of.
Yes.
Okay.
Yes.
Okay.
Okay. This is
So,
it here. Google Colab is literally that same Jupyter Notebook you have in your PC, but this time it's just like an online version. Let's just make it that simple.
I understand. Having it maybe is a system you have somewhere installed. Let's say it's a cloud-based environment. Instead of you to have the local installed programs on your local machine, you can just log into Google Colab and have access to those resources you need.
Exactly. Thank you very much. Thank you.
All right. Thank you so much.
Yeah. Are you still speaking?
Yes, I'm true.
Okay. See all the stuff I said in almost 5 minutes. Aaron just said it in less than 1 minute. So that's it. That's just it. You get all the resources you want to access in your local PC, just access it in Google Colab, and it is very user friendly. In fact, it is more user friendly than that Jupyter Notebook that you use inside your PC. So, yeah. So, thank you very much for this question. So let's return to what we were doing. So now we are working with Numpy. So I said the best way to use it is to use the import Numpy as NP. And I said Numpy is a package in Python that we use when we're performing mathematical operations. So when performing mathematical operations, what you think about is Numpy, at least in the beginner level Numpy. So let's think about, first of all, some properties and attributes that we make use of. Numpy's most fundamental block, that is what it rests upon, is what is called the arrays, Numpy arrays. And it's very similar to our usual Python list. A list normally is something like this. You see the square brackets 1, 2, 5, 7, 9, 16. So this is a Python list. You get, so a Numpy array is very similar to a Python list. So for a Numpy array, this is how we will call it. Remember I said we import Numpy as NP. Import Numpy as NP. That was the first thing that we did. Now we want to call it. So I want to create another thing that looks like this one. I want to use Numpy. So now, for those of you who have never used Numpy, this is how we use it. You first of all call NP dot, because I've called Numpy as NP. So there's no need to write Numpy. You call it NP dot. So I want to create a Numpy array. You get, so I write it NP dot array. You get, so you call the method, the functionality. So we want to create an array, NP dot array, and then put that square bracket inside that represents a list and write it 1, 2, 5, 7, 9, and the last one which was 16. You get, so let's run this. So if I print something, if I print L, I should have that Python list that I created above. You get, so now if I go down, if I go down and print. Let me print a watch. See what we're going to have. You get two of them came out literally in the same form. But I want you to see something here. Let us check their types. Let us check their types. Two of them look like the same thing. But let's see something here. Let me comment these two statements. Is it going to be type L? Okay, is it type L? Okay, list. Let's try that for A. Okay. Did you see any difference? Let me watch this. I'm trying to fly. Look at when we did print for those two stuff. What we had initially when we printed them was the two of them came out and seemed as though they were the same thing. When we printed L and when we printed A, you can see difference between the both of them. First of all, from the print statement. Let me still make it just the same way it is above, so we don't get confused. I understand how beginner classes can be. Okay. So look at it. We wanted to check when you printed your L, the L is the normal Python list. This one is a Python list. And this one is a NumPy array. They are very similar. They are very, very similar. Now, for the Python list, when we printed it, look at what it looks like. It has the same way you wrote it at the top, as how it appeared 1, 2, 5, 7, 9, this. You get. Now, when we printed the NumPy array, it still gave us that square bracket. But look first, there's no comma in between each consecutive numbers. 1, 2, 5, 7, 9, 16. You get there's no change in it. There's no comma to separate each consecutive term. Now, when we go again down to checking which type, we learned data type in our first classes. So when we press type, which type of data is this? It gave us list. When we went down to this one, type of A, it gave us. I didn't run this before. You see A, it gave us a numpy.nd array. N means n-dimensional. Get n-dimensional array. So that's the difference between the Python list and the NumPy array. You would always see they are very similar. And you can convert a NumPy array to a list. You can convert a list to a NumPy array. Another way I would have written this thing is, watch me. B, or let's say A equals to, remember the first thing to do, you are using a package np dot, then the functionality that you want to call array. Rather than having to write a big this thing inside there, like square brackets 1, 2, 3. If you have defined a list somewhere before, you can just write the variable name of that stuff, of that list. So if I write L here, watch what I'll have. If I do print A, you will see that what I'll have, you will observe that I've already created a NumPy array. You get it now. There's no need to press type. Once you can see 1, no spacing, no comma, you just see 1, 2, 5, 7, 9. You get. So that was another way. So assuming you have a list already created, you can just put that list into your np.array method, and then you would have your list data structure. I mean your NumPy array data structure created for you. You get that? So let's go into some other operations as they relate to this. So the same things that you do with your list, you can always do them here. Let me copy this. Okay, let us just see this here. So if I do A, the same way I work with list A 0, What am I supposed to have? Just unmute yourself and speak. No, wait. A minus 1. What am I supposed to have? Just unmute yourself and just tell me the response. A square bracket minus 1. What should be my response? Yeah? Okay. Yeah.
Speaking the last
The
number there, that's
the last
16.
10, right? Thank you. 16. Thank you. That's 16. Thank you. So just the same way it happens in list is going to happen here. You get it? But this time you can you can see that what you have as the output here, it is not just displaying the term 16, it is displaying the data type that thing represents. Yes, it's not just giving 16. Anything, even if you convert that 16 now to 1090 something, if you press A square bracket minus 1, it's going to bring it out in this form. I will teach us how to convert these things later, but it's not so necessary now. You get? So the same way, if you press A minus 2, or let's not even do that, A4 or A3. This is 0, 1, 2, 3. So our answer is supposed to be np.int64 bracket 7. So that should be our answer. So it's 7 that will come out. It's 7 that will come out there. So you get it now. So this is just the same operation that we perform there happen. So another thing we can also do is that NumPy gives us the ability to work with more than one dimension data set. I mean, more than one dimension data. Please mute yourself, please. The person that has that stuff on, please mute yourself, please. Yeah. So it gives us the ability to work with more than one dimension of data, and I will tell you how to distinguish different dimensions. You get, and this is not to get you unnecessarily tired with the use of mathematical terms. Please don't. We are not going deep dive into mathematics, so there's no need to even feel that way. So I want to create a NumPy array that is not just the usual one dimension. All these ones that are just writing square bracket 1, 2, 3. Get, some of them are just one dimension, some are not. But I'm going to explain this to you. So I'm still using the NumPy array.
Hello.
Good. Okay.
Hello, good morning.
Good
Please,
morning.
I don't get how you get the NP, that NumPy in 64. Like, echo actually came in that obstructs my listening, please. That's 60.
Okay.
Yeah, where you are, I don't know how you get it. I'm so sorry.
Okay. It's fine. So this is it here. It is just normally. Normally, please anytime you speak. Yes. Okay, let me just respond to this one that this lady asked. Immediately I'm done, raise your question. We'll proceed from there. Are we good? Okay, I think a
yes.
Yeah, thank you. So A square bracket 3. Normally, if it was a list, the way we call list normally, look at it. Remember the way we read this thing is 0, 1, 2, 3, 4, 5. So if I do A3, it should give me 7. If it was a list, it should just give me 7. But you are not working with Python lists, you are working with NumPy arrays. I repeat that again, you're not working with Python lists, you're working with NumPy arrays. So how we call it first is that we do np.array, and then we put in the set of numbers that we needed in a square bracket. We already have the set of numbers up here. Let me copy this guy so that we'll keep using it as we go. We already have that stuff defined here. You get, so I just did np.array, and then I copied the L. Instead of writing all of these things again, I just copied L and put it inside, and I print A. So this is what I'm having. You get, so if I want to call, okay, let me call the first term. It will be A0, and I'll use 0 to call it. So watch this. Let's see what we get as our output. It is 1, but this thing is just telling you that the data type is a NumPy array. You get, I don't want to go detail into this stuff. It's going to cause a whole lot of confusion. But the most important thing here is this one here. It's just telling you that the first index there is 1. If I want to call this 5, what is the index that represents 5? That's 2, because the first term, the index is 0, index 1, index 2. So watch, if I change this 0 here to 2, let's see what happens. You see, it is still np.int64, then you have 5. So this 5, the most important thing to pay attention to here is just the 5, the 7, this thing. Let me do one last one, -1. So 16 is what I want to get. Is the last term that I want to get. Watch. 16. That's the most important thing for now. Forget about this in 64, the np dots. The lady that asked the question, I hope this is clear, right?
Yes, thank you so much.
Okay, it's fine. So another lady wanted to ask a question, please. Can you ask a question now? So progress. Okay.
Excuse me.
You wanted. Okay.
That int 64, is it indicating the data type? Is it an integer or something?
Okay, yeah. First of all, int represents integers. 64 is a type of byte calculation that is used in programming, especially Numpy has the ability to. The thing is, numbers have different weights. I really don't want to go into that because I didn't hear you well. Sorry, I didn't hear what you said just now really well, please.
I'm not the one. I think it's somebody else.
Oh, okay. So that 64, it's not like it's not necessary, but we've not even gotten to point where we really need to put that into very detailed consideration. And trust me, it's not even going to be a problem yet now. I just understand that going into this thing will lead us into some deeper stuff that may not be necessary for us to dabble into now. And the funny truth is that even with the little ones that you're learning now, this stuff that seem very inconsequential. It's funny how it's not I've heard. I've seen people that have gotten jobs with just some of these little things. In fact, they don't even know codes as much as some of you who are here. That's the funny thing. So let's just and please continue to ask your questions, whatever the questions is that you have, just ask them so that we can know how to help you and get things out better. So I was talking about something I said we want to create a two-dimensional array. We don't want to do a one-dimensional array like we've been using before. Watch me. I can't hear you very well, sorry. Sorry, I can't hear you very well, please. Okay, most likely she jumped off the call or our network's bad. Okay, let me proceed here. The same strategy that I applied here is what I'm going to apply in creating this. So I want to create a two-dimensional array. The same strategy that I've applied at the top is what I'm going to do here. So let me create a Python list. So I'll make it a list of lists. You get a list of lists. A list of lists. So watch this. So this is a list normally. So imagine me writing something like this: 1, 2. I'll create another listing again. I'll do 3, 4. And then I have 5, 6. I want you to see something here. Please let me increase the screen in case it is not very visible. Don't know if anybody might have an issue with it, but let me just increase it. Okay, so look at this now. What we are having is a list or several lists inside a bigger list. Get several lists inside a bigger list. So you have 1, 2. This is a list here. This is another list. Get, and this is another one, all inside this final big list here. You get, all of them are inside this final big list here. So if I come here and do this, I want to explain something, please. So I wrote np.array, and then I put, so this why I wrote here is that I'm putting this stuff, is this stuff I'm trying, this list of lists is what I'm putting inside here. So let me print, let's print X. Let's see what X will look like. Okay, look at what it looks like. I'm using this thing to dabble into the explanation for the structured data stuff you get. If you look at this now, what you are seeing is it's still just the same way here, because you cannot see commas. There are no commas. You can't see, you are not seeing 1, 2, 3, 4, 5, 6. Now you have, this is actually a 2-dimensional array. It's 2-dimensional because of 2 major things. One of which is the fact that you have okay, on a more basic level, let's take this as a 2-dimensional array because we have a list of a list. We are going to make it 3-dimensional as time goes on. Okay, if you have more than one list inside the list, like you have this 1 and 2 inside this external big list here. They have the whiteboard. Look at this. This is no longer 1 dimension, it is 2 dimension because it is sorry. Okay, sorry. Please excuse me. Let me do something here. Trying to let us do np.array. Then we put that b inside it. Okay, see. Look at what you have here. This thing is actually not a 1 dimension. It is a 2-dimensional array. And the meaning of that 2 dimension is that it has more than one column. Permit me for using that term. I'm trying to be a layman here. When you're understanding dimensions, when you're dealing with data structures, like when you're dealing with structural data, that is data that is in the form of tables. In fact, see it this way. If you have a table that has column and rows in tabular data, okay, let's just go to, let me explain something here. Okay, let us use this image. Okay, I'm not going to load the page. Look at this. I hope you can see my screen. This table 6 here. We have, how many columns do we have here? Let me see, because it's even me myself, I could not differentiate between the rows and columns before. So let us see if we have people like people. How many rows do we have? How many columns rather? Columns.
4.
4 or 5?
4 columns.
5 columns.
No, count the.
I have confused the person that said the right thing.
4 columns, 5 rows. 4 columns, 5 rows.
Thank you.
Yeah.
Thank you. It is 4 columns, 5 rows. 5 rows. I just said rows. Forgive me. I'm an able man. We have those kind of morphological interference at times. Okay.
We have also.
No, we have 4. We have this table 6. There are 4 columns. See this one, this X1.
Yeah, I know the rows.
Okay. Yes. the rows here are 5. This is 1, 2, 3, 4, 5. You get.
Yeah.
So when you want to understand dimensions, let me come back here. We are trying to understand dimensions. The most basic way to understand it is how many columns do you have? The most basic way. There are other things that there are other factors that help you decide if this is a social dimension or this is a social dimension. But I just want you to understand at the most basic level, check how many columns you're having. If you have 8 columns, then possibly call it an 8 dimension stuff. So look at this. You have 1, 2, 3, 4. This is 4 dimensions. If I come back to this thing now, let's come back here. The last line of code, that's the previous line of code. You see the way this is printed out. You have okay, how many records or rows? We have this as 1. This one here is 1 record. This is another record 2. This is another record 3. You get. But if you this is row 1, row 2, and row 3. Row 1, row 2, and row 3. But for the columns, you have column 1 and column 2. This is a 2-dimension array. It is 2-dimension because it has just 2 columns. There are other things that maybe not all what I've said to help us understand what like how many dimensions we have in a given array or list. So this is a 2-dimension stuff. Yeah, this is a 2-dimension. It is not only because you have just 2 values, you get, but in the meantime, once you are having more than one, like you have a list of a list, you get, like how we defined this thing here. For this B, you have, this is a list 2, 3, but it is placed inside a list. Once you're having a list of a list, what you're thinking about, you get, what you're thinking about is, okay, this is going to start going into several dimensions. You get. We are going to touch other things that will still reinforce this knowledge properly. You get. So you have this 1, 2. So this is a 2-dimension stuff. If I go over and let us create another one. Let's call this one W. So if W, this is a list. We have another side. You have 3, 4, 5, 6, 7, 8. So I think let's put all of this also inside the list. Okay. Comma, another list. Let's say, okay, fine, let's just leave only these 2 lists here. So what? So now let us convert it like this. This is a list, but let's convert it into a Numpy array. So let's say name it W is going to be empty.array. So we just put that W into it. Let us print this thing out. So print W. Print W. So you have, this is stuff. You see, you have 1, 2, 3. You have 1, 2, 3. This is a 3-dimensional array because you have 3 columns. There are 3 columns and there are 2 rows. When you print this thing out, what you always see is row, comma, column. There are, please, whoever you are that is speaking, please try to mute yourself. Thank you. Okay. So let us start going into some of the properties. I will take questions soon. So some of the properties. Let us use this W. Let us check itself.
Binomial division or not?
Okay. Okay. Okay, I'm sorry, it's 8 because how many elements are in the list. Please, I'm going to explain all of these things. Mr. Adebayo, I think that's your voice. If I'm not saying, I said it. Please mute yourself. Please mute yourself, please. Your voice is interfering in what we're doing. Thank you. Okay, these things are literally attributes. You get these things are literally attributes that we use to like you have created a particular numpy array. Let me create another one again. np.array. Sorry for doing it. I'm doing it so many times so that beginners will get used to it. Okay, this is 2,7. This is 0, 7,9. So look at this here. Okay, w.end watch. So you should give me okay. Okay, this is a two-dimensional array. See this ndim is just an attribute that you just attach to the end. You just use a dot. You have created that is, and anytime you see somebody calling dot something, most times after you have created a particular data structure in Python and you see dot something, is either calling a method or an attribute. You are either calling a method or you're calling an attribute. The difference between methods and attributes is this. At times, methods, they call them as functions. Methods will always end with this type of brackets. These ones are like functions, just the same way functions used to end with the open and close brackets. But so we are dealing with some of the attributes. We may also have to talk about some functions or some methods too now. But now this ending, if you try to call it this way, it's going to give you an error message because it is not, that statement is not supposed to be a method. This is an attribute. Don't make that mistake. Even if you make the mistake, you will learn. Once you see the error, you just remove that stuff and you get that. So you have it. So this two means that this is a two-dimensional array. If you call it for this thing, it's also going to give you two, and which will annul the statement that I made above that said that that you know dimensions by how many columns they are. But we'll get to somewhere when we start working on structural data. That'll make me explain why I said that thing, because there are sometimes when we have to do PCAs. That's a way of reducing the dimensionalities of a particular data frame or data set. Or when we get there, we'll do that. So now this w.item size. So let me ask again, generally, this item size that you are seeing here, is it a method or it is an attribute? Please try to respond. .item size, is it a method or an attribute? I just want to be sure that we got what I said when I was dealing with this one here. Item size, is it a method or an attribute?
Sorry, Sir Ezekiel speaking. I didn't get it, so I can't say. But it looks like a method.
Okay. Who else has something to say? Thank you very much, Ezekiel. Who else agrees or disagrees with him? Okay, so that means everybody agrees with him, even though he was wrong. You tried, Ezekiel. But look at it. Methods will always end with this, just the same way we write functions. Methods will end with this bracket. You see the open and close brackets. And because item size is not defined as a method in NumPy's curriculum, in their own functionalities, they do not define item size as a method. If you come and, because you know that there's a functionality like item size in NumPy, and then you mistakenly, even me, I make that mistake, and the mistake doesn't even mean that you don't know what you're doing. Once you see the error message, it will remind you that, oh, this thing is not supposed to be called this way. Let me remove this stuff, and once you remove it, you will get what you desire. If I call this now, see, it is giving me this error. What actually, there is no method like item size. If I remove this stuff now and I call it, the error will go away. This is an attribute. Now this is the difference between methods and attributes. Let me say it again. Methods would always end with that open and close brackets, but attributes, you just write them and forget about anything. Did you get that description? That's difference between method and attribute now. You get it now?
Yes,
So
sir.
methods will always, methods will end with the open and close brackets, and then the attributes will not end with any of those. You just write it. So w.shape is an shape is an attribute. Yeah. So 3 comma 2. The meaning of this 3 comma 2 is, but let me do this before let me write print w so that you can see everything well. Print w. Okay, print w. Thank you. Print w. So this 3 comma 2, please pay attention to this thing. The first thing you always have anytime you try to check your shape is always your row. So it is actually row, comma, column. You get, or let us call it yes, number of rows, comma, number of columns. They will not write it for you, but you will know. So if you're asked how many rows are here, you get how many rows are here in this W, how many rows are here? The number of rows you have are 3. 1, 2, 3. You get, and the columns are just 1, 2. You get it now. So 3 comma 2 means row before column, and that is always the convention. You always see rows before column, rows, column, rows, column. So item size was used to get how many elements are here. Dot shape showed us actually the shape. The shape speaks about its dimension. You get, so it is 3 by 6. So dot size and dot shape at times are used interchangeably. The size is like the calculation of the. Yes.
Hello, sir. Please,
Yes, I'm with you.
how did you get? Please explain what the item size means.
Okay. W byte size. Excuse me. That's true. Excuse me, let me comment out this. Let me look. There was one stuff we carried before. Okay, let's see this guy. I think this was the last place we defined a coming. Okay, sorry. I made a wrong statement. It is not the number of elements, it is the byte size. I'm going to explain that to you now. So let us use item size. It's still what it will still give you 8. Yeah, it will still give you 8. Data types in Python, you can change, especially when you're working with integers, you can change it to different formats. It's been a long time since I worked on this stuff, but let's see something. Watch. I want to try. I want to try changing this stuff. Please. I didn't want to go here before. This was that stuff. There was someone that asked a question about that np.int64 we're seeing before. I don't know if you remember. Somebody asked that question. This is that stuff I was trying to avoid. Okay, this int64. So that int do we have? If I make 32, is it possible? Okay, did you observe something here? When this thing was 64, when it was 64, did you observe that it was showing us 8, right? Abi?
Yes.
When we check item size, it was showing us 8. When I change this thing to 32, watch. Item size is 4. Sorry, I made a wrong statement before. Item size does not represent how many elements are in the stuff. It's rather describes the size of the number, like the weight that the number carries. You see, it's when you're doing programming that you realize that 8, like just writing 8, the normal, the same 8 you write in your papers, you get, they don't mean the same thing. In fact, there are some. Okay, this is what I mean. If we create 2 different files, 2 different Python files, and in one of the Python files, I try to create a Numpy array, and all the Numpy array, when I'm done creating them, I add this statement, this stuff that I did here. this np.float32. If all of them, I make them np.float32, all of them at the end of everything, and I create another Python script using NumPy arrays, and I make them 64 bits. When we save those two files and we try to check their size, meanwhile, it is the same numbers. The only thing I changed was I added this thing and changed the data type. I mean, the byte size of the number. When I try to check the properties and check the size of those files, you see that the files will not have the same. It was the same stuff that I stored inside them. But how come they don't have the same size? The reason is actually because in programming, there's something they call byte. It helps us define weight, like weight of numbers. Computers don't understand letters; they understand numerical values, numbers. You get, so there's a way that this stuff is actually represented in order to when you start working on deep learning algorithms, especially when you're using frameworks like PyTorch, you will see the need for knowing some of all these things, especially when you're trying to optimize and deal with some big challenges that you're having that are related with the capacity of your system and the type of values that you are converting some of the stuff you are working with. You get, so actually this 8 is a representation of the byte size. Once I change this thing now to, I think 128 should give us 16. 128. Okay, 128 gives us 16. So the default byte size in Python in NumPy array is always 8. Do you get that? It's just telling us the weight of those numbers. Please, did I get that clear? Did I get that clear?
All right.
Yeah, so it is not the cardinal, it is not counting how many elements, unlike what I said above. Sorry about that. It's actually telling us the weight of each of the numbers. As we progress, you will see the application. The truth is, application makes all of these things more understandable. So let's still progress. So what other things we doing in NumPy arrays? We can.
If I drop a question in the chat.
Okay. I'm getting an error. Okay. Okay. The error you are getting is because you did not put them inside an enclosed list. If you observe, it's supposed to be a list of a list. The person that asked the question, can you hear what I'm saying? Please, can you hear me? Please, am I still audible, please? Am I still audible, please?
I can hear you.
Okay, observe your codes. This is supposed to be a list of
You are audible. You are audible.
Okay. So I'm saying this is supposed to be a list of a list. You did not enclose this stuff inside another list. Watch. Look at my own lines of code at the top here, where I did that same stuff. Look at it here. See, there is a square bracket at the beginning and at the end. You get? Do you understand me?
Okay.
Yeah. So it's supposed to be a list of a list. Don't just put in several lists, yes, in it. So that was what happened. That was what caused that issue. Okay, learning to debug is one of that things you would learn. Okay, so let's learn how to in Python. So we are working with some types of networks. As time goes on, over the month, you get to experience them. You may need to initialize certain values. This is where we make use of the concept of matrix, but we're not literally doing any of those mathematics here. Initialize arrays with some numbers. Okay, so do np.0. So you can. What this one does is it just helps you create a NumPy array that contains zeros. So you see np. If you observe everything I do, I'll first call the package. So you see np.zeros. What I want to create is actually a numpy array that's the only thing that is contained in them are zeros. You get zeros. But you need to specify something. What you need to specify is the shape. You get, if you just tell it and watch this, if I just tell it, okay, let me specify a shape first. 3,2. You get, so that means there will be 3 rows and 2 columns. So watch this. The number is not attributes to zeros. The attribute zeros. Oh, sorry. Please let me be sure I'm not forgetting how to write English language. If the last value in an English, let's say in a noun is a vowel letter, do we add e to the end? Like, do we add e if we want to make it plural? We add e now, right? I think that was where I was trying to get this error from. Okay, so this is not English. This is Python. Python is not English. That's English language. This is Python language. This is how Python understands. So you're not writing zeros like ES. That was where I had that issue from. So NP dot zeros. Observe now. You see it here. You have, look at what you have in this 0 point. To just tell you that it is not an integer. It is a float. You get like 0.0. You get, so that you don't ask me what's the meaning of this point. It's 0 point something. You get. And that's sign. So if I do print A, I think it's always better that way. So you get this. So you can also initialize ones. So let us do for ones. So let's say b is equals to np dot ones. This one already ends with e. So let us make this one 1,4. So let's print B. Please, am I still audible? Okay. Yep.
Yes, you are.
Thank you. Did not save for some reason. Sorry. Something distracted this, so it didn't save. You get now. See, look at this. This is just giving us it's giving us ones, because what we put in here was that we wanted a dimension of 1,4 that is just 1 row and 4 records. I mean 1 row and 4 columns. You get it? So that's having one point. That is a float 1.0. You get 1.0 1.0 1.0 1.0. Let us see the data type. So you get the, I hope it does not give you an error. Excuse me, an error. Should type, right? Okay, float. This one is a float, is a floating point, is a float, but leave that, it's not necessary. It's not necessary. Meanwhile, I do not like that expression that we're having over there, the result. So let us change it. Let's still do 3,2 so that you can easily see it well. 3,2 or 3,3. So 3 rows, 3 columns, 1, you get it. So that ones all through, ones all through, ones all through, you get. So that's about that. Now in Python, you should have, okay, there is this built-in function in Python called range. Watch me. If I write L equals to range 5, let's print L, and see what we have. Print L. Let's see what we have when we print L. Print L. If you print L, you have okay. Let us try to convert that into a list. when we printed early, it still printed out range 0,5. So let's try to see if we can convert that into a list. List L. Let's see, L equals to list L. Please make sure you ask a question if you're okay. See here. I wanted to write a list of numbers from 0. You get from 0. I will count 5 times from 0 in normal Python list. You get, so if I just wrote range 5, to count 0, 1, 2, 3, and 4. All the numbers there are actually 5 numbers, but it starts from 0. Watch this. Let's make this thing 10. You get it?
Excuse me, sir.
Okay, please.
Please, I want to know, when we do zeros and ones, does it automatically mean the numbers that will be printed will be floats?
Yes. All the numbers. If you just do mp.zeros, you get, and you define the shape inside there, inside here. Once you define the shape, the only things that we printed out will just be zeros. For these ones too, the same thing happens. Once you do mp.ones, you get, and then you define the shape inside there, the only things that we printed out will just be ones, only zeros. You get that?
Either it's ones or zeros, it will always be floats.
I didn't get you, sorry.
Anytime we print it out, either zeros or ones or whatever, it will be floats. It will come out as floats, not integers, nothing, but floats.
Okay, it was some of the adjustments I was doing at the top were one of the things that affected this stuff. It is not all. Okay, yes, it will. Okay, one of the reasons why Numpy always does that is because, you know, in the number system, speaking mathematically, the number system doesn't just consist of whole numbers or integers. You get, so it gives you that leverage to have the capacity to when you work with floats, you have a greater capacity to work with larger array of numbers than when you work with integers. For instance, if anybody that uses just integers does not consider the full set of numbers that are enclosed in the real number system. That is, he's not considering things like 1.1.901207. He's not considering all of those stuff. So I think this is the reason why anytime you call this thing here, although this is the first time I'm even having to observe all of these things, I've never taken note of this thing that it gives me a floating point once we call it, you get. But I think that is one of the reasons why this is happening. You get, so it just gives us the leverage of having extra value that could be added, like converting all of these stuffs. Floats make it easier to get a wider range of numbers than when we work with integers. You get, so that is what I think. I've never observed this before, but this point you're having there, it shows that they are floats. Actually, it shows that they are floats.
I think I get it a little because we're working with NumPy, and NumPy actually accommodates floats.
Yes.
But if we're working with other what's it called? I not come out as floats.
They may most likely not come out that way. They will most likely not come out that way. Most likely, they will not. Most likely, they will not. Yeah. You get? Okay. Yeah, it's fine. Thank you. So see, I was trying to explain this range function. If I write range, there's somewhere I'm actually getting to. If I write range 15, it will have every number from 0 except 15. You get every number from 0 to 15, but 15 will not be inclusive. So if I print this out, you have 0 to 14. 0, 1, 2, 3, 4, 5, 6. So this is when you're working with Python lists. Now, in NumPy, there is a variable for this thing. It is called, this one here is called range. In NumPy, it is called arrange. And that arrange is not like the arrange your chair where you have double R. It is just a range. You get that? So if I write something like this, let me still show you another example. Look at this one. Range. Let's say range. Even if I write range 1, 15, what was going to happen here? Okay, so let me convert it into, let me do everything here. Let's convert this thing into a list. Please don't be confused. What I'm doing here is what I did up here. But rather than having 2 lines, I just did 1. So after I wrote my range 15, I just passed it into the list. Do you understand? This stuff here is what I'm doing here. Please just verify that you understand what I just did. Okay, I'll take a silence as understood. Thank you. So let us print L. You see what will happen here. You see, this time it did not start from 0, it started from 1. The reason is because here we defined where we wanted it to start from. If I choose 5, what was going to happen? 5, 15. It will pick every number from 5, but 15 will not be included. From 5 to 15 and exclude 15 from the list sheet here. 5, 6, 7, 8, 9, 10, 11. Are we good? I hope this is very, very clear. So anytime you have the range function, this is actually what it does. You get. There's another thing that the range function does. Let me explain that to you. I've explained in 2 ways. The first one, if you just press range a particular number, it takes it from 0 to that number, but excludes that number. If you do range start from any number to this, it will always exclude the last number that you have. You get. I mean, if you just write range 15, start from 0 till except 15. If you define a number, it should start from the number you have defined, but it's not include 15. Now, there's another way it is used. Let me still give it as L. L is equal to, let's say, range. Watch me now. I'll do 5, 15. Then I do comma 2. Okay, let me still convert this into a list. Sorry. So make it easier for us. And then let's print it out. So observe me. Okay, see. What do you observe? I did 5, 15, 2. This time around, this 2 represents.
The parenthesis is not complete.
Huh?
The parenthesis is not complete.
The parenthesis is not complete. I don't understand, please. Please don't be scared. Please just explain what you mean. Would address it. Whatever it is, we are going to address it. Okay. You are trying to explain why I got the number of values that I got. Okay. I think I understand. But what I got is actually correct. Please let me explain well. If you observe here, in this line here, you have 5, 15 only. So what it does is it takes every consecutive integers from 5, and then it excludes 15. So you have 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. It excludes 15. But here in this code, I wrote 5, 15, 2. So what it does is
sorry, I was thinking that the parenthesis was not complete, but I understood what you did. It will only bring out the difference of 2 from the starting number of 5 before it gets there.
Yeah, exactly. So let me reiterate what he said. When you see 5, 15, 2, what you have is it would bring consecutive terms from the first one that you have. You get it. It will just be adding 2. So after 5 plus 3 is 7. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 2 is 13. You get 13 plus 2 is 15, and 15 should not be in that range. So that's why even 14 was not captured. You get it now. So this is what we have. I'm dealing with NumPy arrays. So let's see how this thing applies here in NumPy arrays. Watch me now. So if I do, let us do it the same way we have been doing. Instead of doing array, I write arrange. NumPy arrange. So what I want to do, instead of writing range, let us start with the first one, range 15. So NumPy range 15. Let us call all of these ones X. So it's X we are going to be calling them. You can call it anything, whatever you wish to call it. I want to call it X. So let's print X. When you print X, so look at what you're having. You get, look at what you're having. You have the same way this one happened at the top is still what you're having here. It's just that just the way NumPy always appear. There will be no commas. You get that? If I go and still do it.
Sorry, please. Is there a difference between numpy arrange and numpy array?
Yes. Numpy array is first of all, it is the building block of anything that has to do with. In fact, it is the fundamental data structure that Numpy stands upon. All these things are still arrays. Watch. Let us try to get the type. Let's get the type. This is still an array. The type. Okay, this is not displaying it here, but it is still a NumPy array. All of them are still arrays. Arrays are just like lists. Arrays are still this. So this is still an array. It's just that this function here is just helping us to. It's just like using this range function in Python programming language normally. But what this one is just simulating the same pattern here. You get. But what you have is still an array. An array is just like a list. You get. So if you observe, this thing still came out as a list. Can you see that? You get. It still came out as a list. So it is still an array. This is just a function that just helps you calculate from the first till any given number that you have. If I do x equals to np.arrange, remember arrange, and I do 0, 15, I'm going to do the same example as I did before. So let's print it. Let's print x. Oh, okay. See it here. Now that I printed without having the print statement or the print function attached to it, can you see that it's brought out array with it? You get. So you can see it now. You get. So if I have x equals to np.arrange, and then I do 0, 15, 2. So let's print out my x without the print statement. See it here. So it is from 0 to 15. It's counting it in twos. From 0 plus 2, 2, 2 plus 2, 4, 4 plus 2, 6, and then it goes till we get to the last value there. Okay, so that's one other function that we need to get ourselves acquainted with. Get. I hope you are good with that. Very, very good.
So the arrange is just like lists.
It's just, yes. Arrange to arrays and arrays. Arrange is a form of array. Array is like lists. Yes. So anytime you call arrange, it will still give you an array. There are other functions that we're still going to test now. Okay, let us look at the linear space function. We will use this when we want to simulate some kind of data very soon. np.linspace. What this thing does is that this one gives you the leverage to not just deal with integers, but deal with floats. For instance, watch this. I want to generate 10 numbers that are within 1 and 5. Normally, if the only set of numbers you know in your head are the usual 1, 2, 3, 4, 5, obviously you cannot get 10 numbers. Look at this thing. The meaning of this thing is how many numbers you want to get within this range. The range is from 1 to 5. You get. So look at the function here. Lin space, like linear space. Lin space. This is very useful. We are going to apply it soon. Lin space. So I want to get 10 numbers that are within the range 1 and 5. So watch out. Let us print this thing. You see what we are going to have. Each of these numbers, they are linearly spaced. What that means is that they are increasing by a particular value. Like there's a common difference for those that used to do math. And I think that value is, you just asked it to simulate it, simulated it by itself. There's no, let me even see whether if I rerun this thing, the stuff might even change. I don't know. It might. Okay, no, it will not change. Yeah, it will not change. What it does is it calculates the space from 1 to 5, and then divides it into 10 equal. It just looks for a series that can represent each of them, or let's say it brings out a sequence for each of the values that you can have. This is the first term, and this is supposed to be the last term. Those of you that did, I think that should be arithmetic progression in maths, linear sequence. This is the first term, and this is the last term. So just what you're telling is derive 10 terms, which will start from 1 and end at 5. And each of them must have a common difference. That is, they must all be connected by a common number. If you check each of these numbers, this and this, from this to this, it is 0.44444444. From this one to this one too, it's still that same thing. 0.444444. That was what was added. From this to this to 0.4. That's what the linear space function does. I hope that's clear.
Please, can I ask a question?
Feel free, please. Please ask.
Okay, like this, in the plain space. And we want to make the... I can hear you.
Okay, speak.
So I said if we are still using this plain space and we want to reduce the decimal number to like 2 decimal places. So how can we include it in this code?
Okay, let me see if this would work. I'll come in. Oh, does this really work for round 2? Let's see. Okay, it worked. Can you see what I did? I just rounded it up to 2 decimal numbers. Do you get?
Yeah.
Yeah, so this is a method that you add to it. You get? Some of these methods, you still don't worry. As you practice, you get them. You get? But let's act like we don't know about that. There are too many methods in this life that, in fact, we will even die. We will never use them. It's just the ones that we need. We'll keep making use of. That we'll keep making use of. If I wanted to generate 20 numbers, yeah, just 20. As it, you see it, you have 20 numbers already generated. Each of them have a common difference. Yes, with them. So that's it. Let me progress. I really want to go into the use of some mathematical functions in Numpy. Okay, yeah. So let us start learning some mathematical functions in Numpy. But I believe most of, at least what I've done, by the time you practice, you would be able to mathematical functions, method and attribute, Numpy. So let's just go there. So these are the stuffs we start using when we start manipulating data frames or data sets. Okay, so look at this now. If I do, remember that I have created a list, a Numpy array here. This one here, I've already created it as this. So if I do this, a dot mean. Okay, someone to answer this one. Is it an attribute or a method? This dot mean, is it an attribute or a method?
Method.
It's a method, right?
Method.
Thank you very much. Thank you. It is a method because we ended it with the open and close bracket. Yes, thank you.
Bracket.
So look at, so what we want to do now is we want to check for the minimum numbers. So here we are checking for the minimum number in the x variable. So let us see what that gives us. See, it is 1 that is the value. That 1 is actually this 1 is what you pay your emphasis on. This is telling that it is a float 64 byte number. So it is 1. And if you check here, look here very well, what do you think is the smallest number? It's obviously 1. You get? So in order to check for the minimum number in a given NumPy array, arrays are not like lists that can take in any data type. Arrays will only take in numbers, floats, or integers. They cannot work with, they can't work with letters at all. So any type of integers that you have, or any type of number that you have, you want to get the minimum you get that is in the given array, just do x.min, it gives you minimum. You want to get the maximum, call this method again. So this one checks, this one checks for the maximum, gets for the maximum number in the x variable. So let us print it out. You will see that that should give us 5, because 5 is obviously the highest number here. Yeah, so this is 5.0. Okay, so I hope that is clear. You get, so that is it. If I want to get the sum, you get the sum of x. So let us get the sum. You know what? So that we can be applying everything that we are learning. Let us be giving all of these things name. Let's call it n max. N max. So we'll do print n max. Or we can just write n max instead of having to write the print statement. So better still, let's remove that off. N max. So let's print. Okay, 1. So if you use the print statement, it will remove all of those stuff. So this one, oh, sorry, it should be n min. That's minimum there. Min. So let's name this one again. Let's give the variable name n max. So n max. So let's reprint again. Print n max.
Please, I have a question.
Okay.
Hello, there's an. We have something to do. Yes, you need to correct that for me.
Okay. Okay, I've corrected that. Thank you. There's a lady that wanted to speak now, please. Go on. Okay. Okay, so this one is for calculating the sum. So you want to calculate the sum of everything in this x array. You want to calculate the sum of everything here. So this is what we'll have. So just do x dot sum. You see, these things are method. X dot min gives us the minimum number. X dot max gives us the maximum number. X dot sum gives us the sum of all of them. So let's call it. Let's name it as n sum. So n sum. So let's print it. So we print.
Please, I have a question.
Fine, please. Please ask it. Yes.
Yes.
Please ask the
Okay,
question.
this is I'm not getting the.
Please, I can't hear you, please. It seems like I've moved on. Thank you for moving on. Okay, let's do something here. In Python, when you are calculating the sum of a given number, especially when you are working with Numpy arrays, I want to believe that we are following, please. I don't just want to be speaking to the fowls of the air. Okay, thank you. Sorry, it feels like I'm moving really slow. That is the way I feel. I feel like I'm moving really slow, but just to ensure that I accommodate everybody's learning ability. And don't worry, when we start working with data sets and doing real machine learning, would devote more time to that. We can add a few more days than what we have so that we can get it well. Okay, so when you want to calculate the sum, you can calculate sum of rows and sum of columns. You can calculate sum for rows and sum for columns. You know what? Let us create a NumPy array that has that its dimension is like 4 by, let's say 4 by 6. I mean, Or let's just use linear space to do it. Let's use linear space to do it. Yeah. So let's call it A will be equals to np dot lin space. So let's say between 2.5 and okay, let's say 50. Let us generate 100 numbers from it. Okay. Or let's just generate 15 numbers that are linearly spaced from 2.5 to 15. I mean to 50. Let's generate. Oh no, let's not do that. Let's not do that. I want us to have an array that has several columns and rows, that is several dimensions. So let us create a list a list of a list. Let me make this one 3, 4, 5, 1, 0, 2, 2, 6, 9, and one last one. Oh, sorry, I didn't close this. Okay, 0, 0, 7. Yeah. So this is a list of a list. Let's convert it to a NumPy array. I'm intentionally doing it this way just so we can also see some applications. So we have converted this into a NumPy array. Let us print it out and see what it looks like. And I want to perform. Okay, now this is what it looks like. This is what it looks like. Okay. Okay, so this is what it looks like. It is
Can we see the code again?
Okay, this is the code. Again, so this is the code. So I created this list of lists and then I passed it into, I wanted to convert it to a NumPy array so that we can perform mathematical operations on it. Yeah. So we did this and turned it into this. So this is what we have. So now we want to calculate the sum. If we want to calculate the sum here, we want to specifically define, we want to calculate the sum of rows and columns. Sum of rows and columns. Now, this one brings us into the term axis. I'm going to use this in pandas data frame too. So that's why I'm also introducing it here. So we calculate the sum of the elements in the columns. So columns. Okay, come in. Let's say axis equals to 0. Answer something. Come in. Okay, yep. Watch this. What we just calculated are the sum of all the columns. It still gave us an array. Watch. It's like doing for the first column. This is our first column. 3 plus 1 is 4. 4 plus 2 is 6. So we have 6 here. What you use to specify that you are calculating column, that you are calculating for columns. For columns, yeah. Is this axis equals to 0. So axis, anytime you see axis equals to 0, when you're working with pandas or NumPy, it's talking about columns. You are working on a column. You are not just using the whole data set itself. You are picking the columns. You are not using any, and you are not just working with anything anyhow. You get. If normally I just click sum without adding this thing, look at what we are going to have. If I just click a.sum, I get 39. But I want to get for the sum of each of the columns. So I do axis equal to 0. For the first column, I get 6. Second column, I get 10. Third column, I get 23. You get that now? So that's how it is. If I want to do for this time around, I want to do for the rows. We are calculating sum of rows. Get sum of rows of values in the rows. So see what we're going to have here. You get it? Look at it here. 3 plus 4 gives us 3 plus 4 plus 5, that's 12. So we have 12 here. 1 plus 0, 1 plus 2, 3 gives us 3 here. 2 plus 6 plus 9, that's 7. I mean, that's 8 plus 9, that's 17. It gives us 17 here. 0 plus 0, 0. You get plus 7, 7. It gives us 7 here. I hope that is clear. So that's how you perform those operations. You get, that's how you perform those operations. That's very, very, it's very, very, very easy to deal with. Yeah, to deal with. There's another function another method I would have thought of going into, but it may not be so necessary. So we can choose to leave that for now. So let's continue with some other operations. Remember, I said anytime you have a list of numbers and you realize that there's a need to perform a mathematical operation, just convert it into a NumPy array. Anytime you are working in Python and you observe that what you have is a Python list, but there are mathematical operations that you are thinking of doing in them, mathematical operations, just convert it into a NumPy array. It's in NumPy that you can perform most of those. You get those stuff that you have in your mind to do. So let's define two arrays. So here we are going to talk about some mathematical operations. You get like let's talk about the plus, minus, the multiplication, and the division. Let's see how we're going to use them here. So we are going to define some data sets. Let's bring this one also. So let's bring it here. Okay. So let's define B. B will look something like that. A list of lists. So watch. So you have 0, 2 here, 6, 7. It should be in a list. This is 6, 7. But let's now it is just a list, it's just a random list. Let's convert it into an array. So B will be equals to np.array and put your B inside it. Let's see if this is going to work. So if you do A plus B, let's see what is going to happen. Okay. Now who can tell me why this is not working? A plus B. We have A plus B. I think the name of the other guy that responded to me, Ezekiel. Okay, so if you're speaking, I'm really not hearing you well. Your voice is low. The lady that was trying to talk, please. Or except you're not speaking here. Someone should try to respond to this. Why are we having this error?
The number of rows and columns.
Okay, thank you. That was actually correct. Please, once you speak, try to mute yourself once you're done, so that there's no echo in the room. Thank you. That was actually correct. The reason why you could not add, you get, if you have some knowledge in matrix, you would understand what I'm talking about. Meanwhile, not having knowledge doesn't still stop you from doing this. Now, the only reason why you can add or perform any mathematical operation on this stuff is if and only if they contain the same they have the same shape. In fact, just go to your error statement. It will help you well in solving the problem. They say operands could not be broadcast together with shapes 4,3 and 2,2. This is a 4,3 NumPy array. You get, there are 4 rows and 3 columns, but this one has 2 rows and 2 columns. They cannot work. The only way we can make them work is, okay, let us try this and see if it is going to work. So now we have made them Okay, this is 2 rows and 3 columns. Let's see if this will work. Still it doesn't work, even though we have made the columns the same number. You see, so that means for it to work, for it to perform this particular operation, they must be the same thing. 4 rows, 3 columns, 4 rows, 3 columns. So let's therefore make this one 1, 1, 6. I'm just generating these stuff randomly from my head, not from anywhere. So let's just make it on 10. So now let's try to perform that operation and see if it works. Now you see now it works. It's even good to get all those error statements. It helps you, and then if you can read the error statement and understand what it is saying, it will help you to solve it. The errors you get doesn't mean you don't know what you are doing, though. In fact, if you watch YouTube videos online, if you take some courses online, you will see the same thing. The people that are still will make some mistakes, then read through the code and address the issue from what they can see in the code. So that's how you learn to code. So don't be scared of making those errors. So I hope you can understand this. Again, so this is how we do this. Okay, let me assign this to something so that I can perform other operations too. So let's call it n add. So n add is equals to this. Let's see if this will work. So let's do n mul. So I want to multiply. So you have a, this is what you use to represent multiplication. This star symbol, is what you use for multiplication. You get. So let's print n mul. So we print n mul and see what we have here. Oh, you can see it now. Each of them are getting multiplied. Meanwhile, the multiplication you are having is just the normal multiplication. Like anytime you see this normal star, just this normal star, it is the normal multiplication, Please, I'm still saying this. You don't need to know the very, very in-depth of mathematics to do this stuff. Because I'll be making some statements like matrix multiplication and all of those stuff, so that you don't feel like because you did not do. I know people who did not even have a science background at all, who are now into data science. I mean, they are literally practicing. They don't have a science background. Some even ask to themselves. It's very, very funny. So you don't. The only thing that as you advance, you will see the need to understand all those mathematics. But the wonderful thing about it is, if you have advanced to some good extent, you will now realize that learning the mathematics is not as hard as you used to think it was. Because this time around, you are seeing the real-time application. One of the reasons why mathematics seem very vague is because you don't see the application. Once you have seen how it is applied, even your mind, the only thing that may make you as adults not to learn it is that you are occupied with too many things. So to sit down and start reading up ordinary differential equations or all of those stuff, you may not have that time. Like myself, I didn't study any engineering-based course. Yet what I did in school was not mathematics related at all, but because I dabbled into this thing later on, I had to start watching videos later on. And the reason why it became easy for me, even though I liked math, was that I have seen the practical application. So learning those stuff was not hard anymore. So when we start talking about some mathematical functions and terms, Python is going to do all of those things for you. It is later, if at all you're going to research in data science, that's when you may need to start digging deep into all of those things. For now, it's not necessary. Don't let anybody use mathematics as a barrier to stop you from going into it. Like I said, there are people who are not science students who are now doing this stuff. Okay, so there's something they call matrix multiplication. You don't need to know what that is, but you can perform matrix multiplication. Yeah? Hello, sorry, I don't understand. Out of you one class watching this thing. Please, can you mute yourself? That's one mommy have people that's talking there, please. Mute yourself, please, so that we can focus well. You need to feel that, please. Okochi Deborah, please. You are extracting this call.
Not on my end.
Okay. Sorry. So sorry about that. Sorry. Okay. Okay, that stopped. So A dot B. So this one is a matrix multiplication. So you have A dot bracket B. Yes, A dot bracket B. If I try to print this out, print much more. What happened? Okay, let me reduce the dimension. I think that would be shapes 4,3, not aligned. Okay, 3 dimension 1 not equal to 4 dimension 0. Sorry. Okay. You know, please remind me, we perform this operation on another form of data set. Please remind me before the class ends. We'll perform this operation on another, we'll simulate another data, but I don't want to stay there for now. Let me touch some other things before I go back. Matrix multiplication. So I would return to it. Just remind me. Fix that. Okay. We'll fix that now. Okay, so let us talk about okay. Does anybody have any question? I've been trying to fly, and because of that, I'm forgetting that people we have learners here who have questions to ask. Please, is there any question? Okay, so there are no questions yet. Okay, that means everybody's following well. That's good. So let's continue. Okay. So let's talk about slicing. It was one of the things I think I did not do when I was teaching us list, but we can learn it from here also.
Excuse me, sir.
Okay, it's fine. Yeah,
Yes,
it's fine.
I was following until you got to this math null.
Okay, the math more, right? Okay, yeah. So I said something regarding it now. I said, don't worry, we'll go back. There was an error code that came up, and I think it was because of the dimensions of values that I had there. So in order to just go into some other things, I said let us keep it. Once we are done with what I want to do now, I'll go back there.
All right.
Okay, thank you. So let us deal with slicing. Yeah, let's just deal with slicing from slicing and indexing. Okay, so let's just deal with that. Make this smaller. Okay, so let's use a list to understand this. So if you have this, so there are 3 terms in this list. Okay, let me make it more than that. Okay, now you can select just a fragment of this n. It's called slicing. That is, you can just we may not choose to work with everything here. So let's say we just want to work with the first three. Normally, let me just do a recap. If I want to select just the first number, I'll do n0. N0 will just give me the first number. But let's say I want to select the first 2 numbers. How we do it is you do n0, then you put a colon, you get, and then we do. Remember, I want to select the first two. This is the first number. This is the second number. This is the third number. So we want to select just this and this. The way you call it is the third number is supposed to be seen as index 2, Abi, right? This one is index 0, index 1, and then index 2. You get? So we want to select the first two numbers. Select the first two numbers. Get n0 column 2. So what goes on here? Okay. I know you may have a question like, it was 0 column 2. How come this one that is even index 2 is not showing? But that's how it works. The last number that closes it, you get, is not included. It's not inclusive. Watch. If I end this thing with if I do, let's select the first 4 numbers. So this is supposed to be 0, 1, 2, 3, and okay, we want to select the first 1 number, which is supposed to be 6 to 9. So I write 0 column 4. Watch. 4 is not the index of the 4th number. This is 0, 1, 2, 3. You get? But because we want to get the first 4, you end it with 4. So what comes out now gives you the first 4 numbers. Please, you can ask me if you have a question with regards to this. If you're looking for the first 5 numbers, okay, there are already 5 terms there. Let us increase this thing. Let's say if I do this, I'm going to select the first 5 numbers. You get? So this is called slicing. Yes, let us name that something. First five numbers. Select the first 5 numbers.
Hello, sir.
So yeah, please.
Do you have to put that 0? I think the previous ones we did when we are indexing, we didn't put 0 column.
Okay. You can also choose not to put it. Yes, it will still work. It will work. You get, whether I put 0 or you don't put 0, it will still work. Thank you. You get?
All right.
Yeah. So whether you use it or not, it's still going to work. So I put 0, I don't put 0, it's still going to work there. Yeah. Okay. So let's say we want to select the last 3 numbers. Select the last 3 numbers. So that'll be n. And select the last 3 numbers. So what is the index of this number? So this is the, or you can just call it, this is -1, Abi, -2, and -3, right? Yes or no? Who remembers? If you want to call the last term, what do? -1 inside the square brackets, right?
Yes.
Okay. So if this is -1, it means you can also call this -2 and call this -3. Or you can choose to call it from here 0, 1, 2, 3, 4. You get? So there are 2 ways of writing this thing. Is either you write 4, then you put this. This will give you, so you have chosen from 1, 2, 3. The meaning of, anytime you just see only this column symbol, anytime it is just the column symbol alone that you see, what it indicates is that you are picking everything that is within that range. So if I write this, I get 12 to 26 and this. If I still write n, then I use -3, then I put this thing. It will still give me the same thing. It will still give me the same thing. Let me join into using Numpy arrays to explain this stuff here.
Please come again. I didn't view that, what you just did.
Okay, fine. It's fine. Okay. The same way if you want to access the last term, you can use n, then you put your square bracket and put -1 to access the last term. -1 to access the last term. If you want to get the second to the last term, you can use -2. this one -3, this one -4. You want to waste your time? -5, -6, -7 is just a reverse calculation. -1 from here is 0, 1, 2, 3, 4, 5, and 6. From the back, it is -1, -2, -3, -4, -5, and -6 and -7. You get? So here, I did it in two ways. If you are counting from the front, the normal way, you want to get the last three numbers. The last three numbers. So the last three numbers that's from here. So this will be 4. If you just do 4, then put this column here. Just 4 column. Finish. 4 column. That's all. It will select from 4 to every other thing in front of 4. Every other thing in front of that fourth position. Every other thing in front of that fourth position. This 4 represents that is 0, 1, 2, 3, 4. Because we wanted the last three numbers, we needed to check the index of the first one in that list. So the index here is 4. So I used 4. Then I put the column, and you have the next thing that follows it. You get? Then I said there's still another way. Since you call the last term -1, you can call this -2 and call this -3. So you have n, you can just do -3, then you put the column again. It will pick every other thing in front of that -3 term. I don't know if that's explanation was clear.
Understood. Yes, very
clear. Yeah. Thank you very, very much. So let's do that. Let's see how it functions in Numpy arrays. So slicing in Numpy arrays are a bit different because Numpy array has different dimensions. So watch me. So let's create this Numpy array, np.array. So let's make it should be a 3-dimensional one. So this is 6, 7, 8. Oh, sorry. To be a list of a list. This is 6, 7, 8, another one, 4, 2, 1. I need another one. There's no error shown. Okay. Okay, this is 2, 8, -1. Okay, so let's just use it this way. And let me print it out so that we can just see how it looks. Okay, so see it here. So this is what we want to work with. Okay, so this is what we have in here on this list. So we want to slice it. Remember I said this one is the row. These are rows. This is row 1 or record 1, record 2, record 3, row 1, row 2, row 3, column 1, column 2, column 3. So I want to slice. Let us just select only. Let us select only the first column. Remember that I said something before. Recall this, that I said anytime you want to print these things out, you will see rows before columns. If you want to slice it, it's the same approach they are going to take. The same approach is what you're going to take. Rows, then columns. So if I want to slice this thing, just the same approach I was using when I was dealing with slicing of lists is typically the same way that I'm going to do this one. So watch me, but I'm going to select the rows first. So since I have named this Numpy array as A, I have A. This is the next thing. But remember, I want to select only the first column. Only the first column. It means I'm going to select every row, like everything in that row. Like under this row, 7 should appear. Under this row, 2 should appear. Under this row, 8 should appear. You don't want to see 6, you don't see 4, you don't want to see 2, you don't see 8, you don't see 1, you don't see -1. So I will select that would be, because row should come before column, because, and it means I'm going to select all the rows. So to select all the rows, just use this symbol here. You get, watch me. I just use that. Remember, I said anytime you put this symbol, you can use it to select everything. In fact, let me do something first. To select all the rows, the first part is for the rows. Anytime you see comma in this type of slides, once you see comma, I'm talking about columns now. You get, so once I just do that column there, I'm selecting all the rows. At this point, I've not stated that I want to pick a particular column, but for now, what you have is that all the rows are already been selected. We have the same way the stuff is here is what is going to apply, is what is going to come out as. But I have to select a particular column. So what is the name of that column? If you count from here, this is 0, this is 1. I mean, if this is 0, the index, this is 0, this is 1. So if I pick 1, let's see what's going to happen. So can you see what we have now? I first of all explain that what you do here is you get rows, then columns. To select the rows, I want to select all the rows. I want to select all the rows, all the rows, all the rows. First, so because this row, in this row, you are going to pick 7, in this row, you are going to pick 2, in this row, you're going to pick 8. And then want to select then this part, it is the second, only the select only the first column, sorry. It's the first column that you're supposed to pick. So someone tell me, what do I correct here? Because if you observe, I've selected the second column.
Change the 1 to 0.
Change the what to?
Change the 1 to 0. Ezekiel speaking.
Thank you very much, Ezekiel. Yeah, thank you. Taking notes. Okay, so we change 1 to 0. See, then I will change 1 to 0, and then we have what we want to have. Thank you. Get it now. So let's also want to select only the first row. Only the first row. Remember the same way rows and columns. So put a square bracket, only the first row. Only the first row, that's only here. So what we want to see as our output should be 6, 7, and 8. Now observe something. Only the first row. Remember, the first thing that should come should be everything that represents the row, comma, everything that represents the column. Because I'm selecting only the first row. Observe something. We cannot use this symbol. I mean, this stuff. If you use this stuff, it means we are selecting all the rows already. But that symbol can be used somewhere else. You are selecting only the first row, but in that first row, there's this 6, there's 7, and there's 8, which 6 is found in this column, 7 is found in this column, and 8 is found in this column. It means that what you're actually supposed to do is that you are selecting all the columns. But for your row, you are selecting only the first row. You get? So what value do I put in there to select that first row? It should be what?
1.
Remember, it is the first row. It should be 0.
Should be 0.
Yeah, it should be 0. The person that said 1 most likely it was just a mistake. Something I'm sure he knows. So that's 6, 7, 8. So that's just it. You get? Let's do one more. I'll move further also. So I want to select. Select from the second row. I didn't tell nothing for English. Okay, this one I want to select. Let's see how we can write that in. I want to select this one. So how do we describe that in first? So this is our problem statement. Let's convert it into let's function it well. So what do you want to select? You want to select here 7281 or 7821. So this is just what we want. How do we select just that one? So if you check it well, it means we want to select from the second column. We want to select just the first 2. You want to select just the first 2. terms in the second column, and the first two terms too, you get in the third column. And then in the second row, I mean, in our first row, we are selecting from here to here and from here to here. Let me say that again. We are selecting here to here, here to here, here to here. So we are selecting just the last two. Okay, we are selecting the last two columns, but from the last two columns, we only want to pick out the first two terms in the last two columns. Yes, I think that's the English there. Let me say, from the last two columns, select from the last two columns, select the first two terms. Yep. This is, let's find the logic first. Let me print A somewhere above so that we can keep seeing it. I'll print A. We'll just keep seeing it and know what we're doing. So who can tell me what we should do now? Remember, I want to first of all select the last two columns. So let us first of all write the logic for selecting the last two columns. So let us just assume that this is the first part of what we want to do. Let's do that first. Select the last two columns. If I want to select the last two columns, that's this one and this one. You get, so that means I'm selecting all the rows first of all. It should be rows and columns. So I'm selecting all the rows, comma. For the columns, I'm selecting the last two. So I'll index that is from here to this part. So it's supposed to be one, then this. Guess one, then this, select one and every other thing. Look at what we have. Sharp. So this is what we have. So that's the first thing. We did a step at a time. So we've been able to select just the last two columns now. But meanwhile, the problem statement is not for us to select the last two rows. It is half complete. We need to select from this one. We need to select the first two terms. You get? So what do we now do? It means that there is a term. There's something that we are going to omit. There's something that we don't need. Observe in this thing. What do you think we don't need? Which line do you think we don't need here?
The last row.
Eta minus 1.
Thank you. Eta minus 1. So we don't need the last row. That means if you come to this place that to represent the row, remember it's row and column. It means we need to exclude something. So let us select everything except for this. This you select. Okay, yes. Yes. 0, 1, yes. You know, at times it's the simple things that get us confused. But do you understand what I just did now? In the part of the row, only this column symbol selects everything in that row. When I added 1 to it, it means it's going to select everything from the first row. That is, it will select 0 and to select 1. It will not select, this is 0, this is 1. No. This is 0, this is 1. Okay, it should be 2. In fact, that's why we know what we want. So if we print this out, we'll see it. Okay, that means that is wrong. Sorry, it's supposed to be 2. Do you understand what I just did now? I intentionally made that mistake so that we can correct it. I intentionally made this mistake so that we can correct it. Do you get that? Please, is this clear? Is this clear?
It's not clear.
Okay, thank you. It's because I know it's very possible. I struggled with this thing too when I began learning. So I wanted to come down and learn because I'm going to give tasks relating to this when we get into Pandas data first. slicing and this thing. Okay, so see it here. These are problem statements. It's like these are problem statements. You will deal with lots of problem statements in data science. So let's celebrate our little win. So when you are done understanding this, for the guy that said that, you should take yourself out. Just chill somewhere. Just celebrate your little wins. Let this be your little wins. Okay, so this is the problem statement. It said from the last two columns, select the first two terms. From the last two columns, select the first two terms. So last two columns are this and this. So let's first of all select the last two columns. If you want to select the last two columns, the first thing is it means all the rows are going to show. Row first. This is how to select all the rows. Just put this symbol. You select all the rows. All the rows have been selected. And then you want to select the columns. The columns are this and this. All the columns, this and this. If I do one column, it means I'll select everything from index 1 to the right. Everything from index 1 to the right. So let's press that now and see what it gives us. Just take it a step at a time. So if this one gives us this, what we need, they said from the last two columns, which we have just done, select the first two terms. So that means just select, if these first two terms, that statement can be confusing because it may just mean just the first, this stuff here. So let's be careful. But what I mean is that you should say, okay, let's say select the first two rows. I think that's the right way so we don't get confused. Nigerians, Africans are very smart people. You can fail somebody in an exam and he will prove it to you that what he said, that what he gave you was correct because of what you wrote. Meanwhile, you know what you meant in your head. You can't fail him. Let's be guided properly. So you have to select the first two rows. So just the first two rows are just this one and this one. It means we don't need this guy. So you want to select this guy and this guy. You want to omit this guy from what you're selecting. You get. So what you will have here would be from my column. Because initially from my column, this is index 0 and this is index 1. You get, this is index 0, this is index 1. Forget that you are seeing this thing here. This is what you are using as your reference. So I beg. This is what you're using as your reference, not this one here. So this is index 0 and this is index 1. So I start from index 1 and select everything from index 1. So that was what I did. But if you observe, I do not need, from here, you observe that you don't need this particular row. It means you want to omit this row. You have succeeded in eliminating this column. Now let's eliminate this row too. So eliminate here and eliminate here. How do we eliminate this one here? To eliminate this one here, we just took 1. We started from index 1. So now we want to eliminate this row. We'll go again to row. We want to eliminate the last row. So that means we are selecting the first row and the second row. We don't need the last row. If I do this thing and I just put 1 here, observe, this is index 0 for row, and this is index 1. Index 0 in rows, index 1 in row, index 0 in row, index 1 in row. So this thing now would give us, watch this one. I'm not saying it is correct. Because normally when you do your indexing in your usual list, when you practice this more, you get to understand it. It will select every other thing except that given index that you have there. So if this is 0, and this is 1, it means it's going to select this one and it's going to omit this one and every other thing afterwards. But because what we needed was actually this one. Don't worry. We'll get it when there are plenty assignments. But I'm still going to explain this. Don't worry. I'm still explaining this. This will be the last thing we'll do now. What we wanted to select was the first from the last two columns. You get, from the last two columns, select the first two rows. When we did this thing now, we selected the last two columns. That was what we succeeded in doing here, the last two columns. But now we want to now select only the first two. If you observe, there's something that you need to remove. What do I need to remove here now for me to select just the first two rows? Which part? What do I need to remove so that I'll just have just the first two rows? I'm asking, or should I ask and answer it, or should I ask it as a rhetorical question so that you just
The last row. The last row.
The last row.
Okay, thank you. So it is the last row that I want to omit. So because I want to omit this last row here, you called it row. So you go back to your line of code, look for where row is. Row is always the first one, the one before the comma. The one after the comma is the column. So I want to omit the first row. The first row. I want to omit the last row. So I'll select every other thing except that place. And how we do that normally is you put this column symbol. This is 0, this is 1, and this is 2. You get? If I write 1, this is 0, this is 1. It means, remember, this last thing that you indicate is not going to show. The last thing, that one that indicates is not going to show. So if I press 1, let's see if the answer is going to tally with selecting the first 2 rows. Watch. It's not going to tally. Observe, I selected just the first row because I selected 1. Let me take it back to the initial way it was looking. For me to select the first 2 coming down to row, I want one of you who did not have the understanding before to tell me what I need to write here to select those first 2 rows. Don't be scared, just try. We'll still correct you if you're wrong.
2.
Thank you. 2.
Just put 2 after that column.
2, right? 2. Thank you. So you see it now. 2 gave us what we needed. The most important thing is learn how to break.
Okay, so it means the numbering is different from the numbering.
Please, can you come again? Your network is not. You're not really audible.
I was thinking the numbering will start from 0.
Yes, it actually started from 0. What you did there is like 0. So this is 0, 1. This 2 represents this one as 2. That 2 is going to be omitted. It is not going to be counted. That 2 does not. This 2 does not mean first 2 row. No, it's just telling you about the index. Anytime you add this thing here, this 2 is not going to join. It's not going to be among what you are selecting. Do you understand? Yeah. So that's it. That's it. Just make sure you practice more. You should. In fact, the best way I'm going to give you that assignment would be, I will just you are going to create any dimension. You can make the work hard for yourself. You are the one that will bear the consequences finally. Meanwhile, the consequences is not from me. It's just the errors and the stress you go through in your head. But you can do it. They say anything that doesn't kill a man makes him stronger. To make you strong. The assignments will just be, I will share this notebook. I think you already have access to it. All of you that saw it on the group chat, but I'll share it again. So you see the assignment. So the assignments will just be to create any numpy array of your choice. Get okay of any given dimension. Sorry, and then perform the following operations using the description or using your numpy array, using your numpy array, perform the following operations. Yes, perform the following operations. Number 1 is select all the rows. Select all the rows. Okay, you know what? Don't worry. I'll copy these things and put them up here. Just select this thing and transfer them to text. Yep. So let this be an assignment. I want to be just bolding it. Okay, let's take it over to that. So that's there. Okay. So, okay, you want to select all the rows. That's the first stuff you do. After selecting all the rows, select just the first row. So select the last column. Select the from the this even select from your array select the third row. The third row. Okay, the third row only. Let's do that first. Third row only. Yeah, and then the last one just be this thing. Select the first 3 rows from the last 3 columns. Do you know the meaning of this? You know the meaning of this last question? The meaning of this last question indicates that your NumPy array should not be less than 4 dimensions in I mean your column should not be less than 4, and your rows too should not be less than 4. That's the meaning of this last question. Because just select the first 3 rows from the last 3 rows and let me remove 1 and add 1. This one is not necessary. Anyhow, let me just add 1 more just so you also hear. So select the last 2 rows from the first 3 columns. Yeah, so let this be the assignment. So any NumPy array of your choice, just create the NumPy array by yourself. I will always advise you to, just so that you practice what you have learned before. You can create it as a list. Just the way we used to do before. Create it as a list and then copy the list into the stuff. Copy the list into it. Let me do just a brief recap. I think this was where we started from today's class. There's a whole lot on Wednesday's class. We would make more progress. So we started with understanding packages and modules. I said the first thing to do is to download it, and now you download it just to do pip install the package, and the next thing you do is to import the package. And you said you either import it this way by import. If you do it this way, you are importing everything about your package. You get, if you just do import NumPy, you're importing everything. If you import import NumPy as NP, please make sure you do this thing before you start your work. First of all, make sure that you have run pip install NumPy and then import NumPy as NP before you start doing all those your assignments. If not, you keep getting that NP is not a defined. You get that error. So this is supposed to be the first thing that you should do. Once you have done this, then you can now start. Here I started explaining about arrays. I said that's the fundamental block of NumPy. NumPy structure in Python. You get, and you could see the difference between it and list. This one, list has commas. It doesn't have commas. You get, and then started learning some operations about it. Learned about dimension properties, ending, the byte size, item size, the shape, the size. The size is just the multiplication of the shape. So if you have 3 by 2, 3 times 3 is 6. That's the same way everything is. Then we did np.zeros. Okay, we talked about arrange function, then the linspace function, did about mean, sum, maximum. We get talked about how to calculate for rows and then for columns, the sum, you get, and then went into the stuff I said we are going to go back to. Okay, then we went into slicing, and that was where we stopped. Slicing is where we stopped. Yes, and I gave us this assignment. Yeah, so that will be all for today's class. My eyes feeling like I didn't even do much, but that's how it should be. Start at start. So this is going to be all for our lecture today, and I don't know if anyone still has a question, but I think our time is
I have a question.
Okay. Please ask your question. Even though I'm still sharing my screen, I can think of that. Okay, what's that?
Okay, this is my question. The aspect worry.
Okay. The what?
Where we